Okay, so this is going to be a very fast one because there are a lot of questions and we have to do it in a limited amount of time. So let's start. Okay, so suppose the integers 2, a, b, c and 160 are such that the first three terms are in EP while the last three terms are in GP. Then the common ratio and, the common ratio and the common difference are the same for this AP and GP. Then the value of a plus b plus c is what? Okay, so let's do it. 2, a and b, these are in AP, which means that a minus 2 um, is equals to b minus a is equals to something which is x. And similarly you have that the other three terms are in GP, which means that c upon b is equals to 160 upon c, and that's equal to something x. You see, this common ratio and this common difference are the same. Okay, so from this first equation we can get that a equals to 2 plus x, but then b equals to a plus x, which is 2 plus x. So you get a equals to 2 plus x and b equals to 2 plus x is nothing but 2x plus 2. Okay, from this equation you can get that c equals to 160 upon x, and then putting this in this equation, c by b equals to x, you get b is equal to 160 upon x squared. Okay, so now we can equate these two values, 2x plus 2 and 160 upon x squared. These two should be the same. So 2x plus 2 equals to 160 upon x squared. Let's multiply by x squared on both sides and divide by 2. So this would give us x cubed plus x minus 80 is equals to 0. We can clearly see that x equals to 4 is a solution for this, because x cubed, which would be 4 cubed, is 64 plus 4 is obviously 64 plus 4 is 70. 70 minus 80 is negative 10. Well, that's not a solution. I think I messed it up somewhere. Oh yes, this should be x squared. Okay, that's better. So x cubed is 64 and then x squared is 16. So 64 plus 16 is going to be 80. Minus 80 is 0. So x equals to 4 is a solution. So we can just divide this polynomial by x equals to 4. By x minus 4. So doing that, let's do this first. So x cubed plus x squared minus 80. We divide this by x minus 4. So first thing which we need is x squared, so that this will become x cubed minus 4x squared, and then we can subtract this, so that will give us 5x squared minus 80. The next thing which we need is 5x. Okay, cool. So when you multiply 5x, you just get 5x squared minus 20x. So when you subtract that, you just get what do you get? You get 20x minus 80. Sorry, you get 20x minus 80. Okay, cool. So 20x minus 80 is just x minus 4 times 20, so plus 20. Okay, that's correct. So when you divide this thing by that, you just get this thing. So either x equals to 4 or this thing is 0. So you can see that this cannot be 0, because the discriminant for this polynomial, this quadratic polynomial, is going to be 25 minus 4 into 20, which is 25 minus 80, which is negative. So there are not going to be any zeros for this polynomial, which means that x equals to 4 is the only solution. Okay, that's nice. So just erase this completely. So x equals to 4 is the only solution, which means that you can have b equals to 2x plus 2 is going to be 2 times of 4, which is 8, plus 2 is 10. Similarly, a is going to be 2 plus x, which is 6. So a equals to 6 and b equals to 10. And then c is going to be 160 upon 4, which is going to be 40. So c is going to be 40. Okay, so we are supposed to find a plus b plus c. So a plus b plus c is going to be 50 plus 6, 56. Okay, that's nice. Let's see if this is in the options. Yes, it is. So let's move to the next question. Okay, let alpha of n be this thing 1 minus half plus 1/3 and so on till negative 1 to the n minus 1 into 1 over n. So this is almost like a harmonic progression. Just the thing is that every alternate term is negative. Okay, so we are supposed to find something about alpha of 2n. So let's try it out. So alpha of 2n, what's that going to be? That's going to be 1 minus half plus 1/3, the usual thing, so on, and then negative 1 to the 2n minus 1. 2n minus 1 is just going to be an odd number, so negative 1 to an odd number is negative 1. So you just get negative of 1 over 2n, because now n is replaced by 2n everywhere. Okay, that's nice. So you know what, I can write it in a different format. I can write it as 1 minus of half minus 1/3 minus of 1/4 minus 1/5, so on till minus of 1 over 2n minus 2. Oops, what's this thing? 2n minus 2 minus 1 over 2n minus 1, because you see this negative thing is always having odd number in the denominator, so this is also going to be an odd number in the denominator. The last odd number is 2n minus 1, and then there's this thing minus 1 over 2n. Okay, so now you notice that 1 over 2 is obviously bigger than 1 over 3, so half minus 1/3 is going to be a positive quantity, but then you negate that from 1, so you are this thing is going to be less than 1. Similarly, you once again take out something positive from whatever this thing is, so you are once again reducing that quantity, and it keeps on getting reduced till this thing, and now this is obviously negative, so even that reduces the quantity further. So we can clearly say that this is going to be less than or equal to 1 for all n belonging to real, for all n which are, I think, integers. Yes, no, not integers, natural numbers. Okay, so for all n belonging to natural numbers. Okay, that's correct. And then there's going to be another representation of the same series. Okay, so you can write 1 minus half as half obviously, and then there's going to be plus 1/3 minus 1/4 plus 1/5 minus 1 over 6, and this keeps on going till you get 1 over 2n minus 1. Oops, 10 minus 1 minus 1 over 2n. Okay, so all these brackets are going to be positive quantities, so when you are adding these things to half, you just get a number which is greater than half. So this is going to be greater than or equal to half for all n belonging to natural numbers. So for all n belonging to natural numbers, now you can just cross verify what I just said. You put n equals to 1 in this thing, so you just get like negative 1 to the 0 power is 1, and then 1 over 1 is obviously 1, so alpha of n would be 1. If you put n equals to 1, which is obviously equal to 1, so it should be less than or equal to 1. When you put n equals to 2 in this, you just get 1 minus half, which is half, so this is obviously equal to half, so it should be greater than or equal to half, which means that which means that only this is the correct option, because over here this is a strict less than 1 inequality, which is not correct, because it should also consider the case where it is equal to 1, and similarly over here it should also consider the case where it is equal to 1 and equal to 0.5 or half, but over here it is in fact considering all the cases, so this is a correct option. We don't know if this is correct or not, but I don't think it's going to be correct because we already got a correct option. Okay, let's move on. Okay, so suppose what happened, suppose a and b be two positive real numbers. Suppose a1 a2 are two arithmetic means, which means that a1 and a2 and b arithmetic means between a and b. So this thing is an ap, which means that a1 plus a2, you just can see what we are talking about. Okay, cool. Which means that a1 plus a2, that's going to be a plus d and b minus d and their sum, so that plus d minus d will cancel away and you will just have a plus b, and then you have g1 g2 are geometric means between a and b. So a, g1, g2 and b, this is going to be a and gp, which means that when you multiply a by r you get g1, and when you divide b by r you get g2. I should say like divide by r, so whatever, which means that g1 times g2 is going to be ar into b upon r. So g1 g2 is going to be ar into b upon r, which is just ab, because that into r and upon r they cancel away. Okay, cool. What about this thing? H1 and H2 are two harmonic means between a and b, which means that 1 over a, 1 over h1, oops, what is this, 1 over h1, 1 over h2 and 1 over b, this thing is an ap, which means that similarly if you can just kind of add these two up, 1 over h1 and 1 over h2, you just get 1 over a and 1 over b. So 1 over h1 plus 1 over h2 equals to 1 over a plus 1 over b, due to the same logic which we applied for this case, right? It's just going to be 1 over a plus d and this is going to be 1 over b minus d. So in effect you just get this thing. So from this we can say that h1 plus h2 upon h1 h2 is going to be a plus b upon ab. But now if you remember, a plus b is the same as a1 plus a2 and ab is the same as g1 g2. Okay, from that we can say that option, oops, what's this, from this we can say that option a should be the correct one, because g1 g2 upon, okay, just simplify this further so you can see what we are talking about. So I'm going to send this g1 g2 to the left hand side upon h1 h2, and we are going to send this h1 plus h2 to the right hand side. So it's going to be a1 plus a2 upon h1 plus h2. So this is option A. Okay, cool. Let's move on to the next question. If A, B, C are in harmonic progression, then so if A, B, C are in harmonic progression, that means that 1 over A, 1 over B and 1 over C are in an arithmetic progression. Okay, so the first option is A upon B plus C minus A, and then B upon, oh, this is weird. These are in HP. We don't know if this is in HP or not. Okay, this is creeping me out. Let us see if the first option is correct or not. So if these are in HP, then the reciprocals should be in AP. So you would get B plus C minus A upon A, and then C plus A minus B upon B, and then other stuff. This thing is an AP. So what we can do is that we can add 2 to each term and still it would be an AP, because that's just how an AP works. The common difference should be the same. It does not like say that even if we like add some common constant to everything, it still keeps the common ratio, the common difference the same thing, right? So if you just add 2 to this AP, I mean 2 to every term of this AP, you still get an AP, right? So when you add 2 to every term of an AP, of this AP, you just get B plus C minus A plus 2A, which is going to be A plus B plus C over A, and then A plus B plus C over B, and A plus B plus C over C. This should be an AP, and this is because it's just a scaled multiple of 1 over A, 1 over B, 1 over C, and we just scale this up by A plus B plus C. So like if you just reduce this series by A plus B plus C, I mean you divide every term of this series by A plus B plus C. If this was an AP, then even when you just divide by A plus B plus C, it should still be an AP, which means that 1 over A, 1 over B and 1 over C, this should be an AP, which is in fact an AP, because we are already given that, which means that the first option is correct. So now we don't need to check for these options, and these might be correct, but we don't care about that. And similarly you can do all these. You can just check if these are correct or not. Like this seems an easy thing to do. Let's go for D. So a upon b plus c, b upon a plus c are in AP. Well, yes, this does seem like these are in harmonic progression. Okay, that's correct. So even D option is correct. Was this like a multiple choice question? Well, we don't know. What about this one? A minus b by 2, b upon 2 and c minus b by 2 are in GP. Oh, eh, are in GP. Okay. So like b square upon 4 should be equal to a minus b upon 2. Um, well, I don't think this is correct. What about this one? 2 upon b equals to 1 upon b minus a plus 1 upon b minus c. Well, 1 upon b minus a to b minus a plus c upon. No, I don't think this is correct. I think a and c, a and d were the only correct options. Let's go to the 13th one. Just erase everything right now. Let's go to the 13th question. The sum to n terms of the series s equals to, and yeah, you can just check see if b and c are correct or not, because I'm lazy, so I'm not going to do that. Okay, let's go to the 13th question. The sum to n terms of the series 1 squared plus 2 square 2 into 2 square plus 3 square plus 2 into 4 square plus 5 square into 2 into 6 square is, wow. Okay, so here's what I'm going to do. I'm going to write it as 1 squared plus 2 squared plus 3 squared plus so on till obviously you have n terms. So this thing, this 2, this 3, this 4, this will continue till n, and depending on if n is odd or even, you have other, like you have choices of what it's going to be. So it goes on till n squared, and then there are some leftovers, because you see this is supposed to be 2 times of 2 squared, so this should be plus 2 squared plus 4 squared and so on. Now it depends if n is an even number of, or if it's an odd number, so it's going to be n minus 1 squared or n squared, depending on actually 2 into this thing. But yeah, okay, that's good. So it's going to be n minus 1 squared if n is an odd number, and it can be n squared if n is an even number. Okay, so this series can be, okay, so this is just going to be the sum of the squares of first n natural numbers. Well, we know there's a formula for that, which is n by 2 into 2n plus 1 into n plus 1. I think this is the formula. Well, no, it should be n by 6, I think. Yeah, that's more like it. Well, whatever, there is a formula like this. Just see whatever. And then there's this thing, plus 2 squared plus 4 squared all the way till n minus 1 squared or n squared, depending on if it's odd or even. So what we can do is that we can just factor out a 4 from this. So you get 4 times of 1 squared plus 2 squared plus 3 squared, so on. And then if it depends if n is even or n is odd. So if n is odd, then it's going to be n minus 1 upon 2 squared. If n is even, it's going to be like the same thing, almost the same thing, just n upon 2 whole squared. Okay, so now once again we can use the formula for the sum of the first n natural numbers. So this is going to be the sum of the first n minus 1 upon 2 natural numbers. So this is going to be n by 6 into n 2n plus 1 into n plus 1. I'm really doubtful if this formula is correct or not. I think it's the correct formula, whatever. So plus 4 into now this is a tough choice if you want to figure out if this is okay. Let's take both cases. So 1 square till n minus 1 upon 2 whole squared. This is just going to be n by 6, which is going to be n minus 1 upon 2 upon 6, which is going to be n minus 1 upon 12, into, you have 2n plus 1, which is just n. That's nice. And then you have n plus 1, which is n plus 1 upon 2. Okay, which when you just kind of simplify, just get n by 6. So you do have an n plus 1 common from this, so you get n plus 1 common, and well, you just have an n common as well, so like that's nice. Actually, you even have upon 3 common, so the remaining stuff is obviously 2n plus 1 upon 2. Then this 4 upon 12 is 3, and then upon 3 is obviously taken out, so that's completely gone. Yeah, this n minus 1 is remaining, this is taken out, this is taken out, but this 2 is remaining, so this n plus 1 upon 2 is remaining. Wait, you know what, just take that out as well. So we will just take that out as well. Okay, that's better. So this is going to be plus n minus 1. That's it, that's the whole thing. So when you simplify this, you just get 3n. So this is going to be n upon 2. So this is going to be n squared upon 2 into n plus 1. Like this happens if you take the first series where n is odd. So this is going to be n squared by 2 into n plus 1 if n is odd. So half n into n plus 1 squared. Oh, this is not what we wanted. Yeah, this thing when n is odd. So B is the correct thing, right? B is the correct option. Now we want to figure out what happens when n is even, so just erase everything. So we will be erasing this. Okay, oops, sorry, what happened? Okay, so if you take this series instead, what you get is, well, you get n by 6, which is n by 2 upon 6, which is going to be n upon 12, times 2n plus 1, which in this case is just, well, n plus 1, and then you have n plus 1, which is n plus 2 upon 2, I think, yes, n plus 2 upon 2, and it's like curly bracket, whatever, round bracket. Okay, let's simplify this. So we can factor out an n and an n plus 1 from this. So n into n plus 1 can be factored out. Then this is going to be 4 upon 12 is just upon 3, and then upon 2 is just upon 6. So you can factor out 1 over 6 from this. So just put down a bracket. It's going to be 2n plus 1 plus the remaining thing is n plus 2. Okay, so this turns out to be, what's this? This is going to be 3n plus 3. So that will be n plus 1 upon 2 when you divide this by 6. So n plus 1 upon 2. So you will have n by 2 into n plus 1 squared. Oops. That's nice. So when n is even, you just get n by 2 into n plus 1 squared. Okay. So let's see where is that option. So you get, yeah, there's the option, half into n plus 1 squared when n is even. That's correct. Let's move on. The sum of the series 3 plus 33 plus blah 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 plus 333 all the way till n terms. So this is what it's going to look like. This is going to look like 1 over 3 into 9 plus 99 plus 999, and it keeps on going like this till you get 999 till n nines. Okay, which by the way is just 1/3 into 10 minus 1, which I'm going to purposely write as 10 to the 1 minus 1. Then this is going to be 100 minus 1, which is just 10 squared minus 1. Then 1000 minus 1, which is just 10 cubed minus 1, right? So 3 nines, 10 cubed minus 1, 4 nines, 10 to the 4th minus 1. It keeps on going like this till you finally get 10 to the n minus 1. Okay, so this is going to be 1/3 of, well, how many of these minus 1s do you have? Exactly n minus 1s. So, and what about this series? 10 plus 10 squared, 10 cubed, all the way to n. There are going to be n terms in this series, and the common ratio is 10. This is in GP. So we can use the formula for sum of n terms of a GP, which is going to be the first term, which is 10 times the ratio, which is 10 to the to the number of terms, which is n minus 1 upon 10 minus 1. 10 minus 1 is just 9. Okay, and minus n obviously. So this can be written as, well, just take out a 1 upon 9 from the inside, so it's going to be 10 to the n plus 1 minus 10 and then minus 9n. Let's see if this is in the options. Okay, so you have, oh sorry, it's 61 over 27. When you take out a 1 upon 9 from this inside stuff, you just get 1 over 27. Okay, so it's going to be 1 over 27 into 10 to the n plus 1. They're supposed to be minus, or they minus 9n minus 10. Oh, this is the correct one. Oh, so they intentionally like flip this to confuse us even more. So B is the correct option. Okay, let's move on. The sum of the first 24 terms of a GP is 2, and the sum of the reciprocals of the first 24 terms of that GP is unity if the product of the first 24 terms of the series is 4 to the n, where n belongs to national but the family of n. Okay, sum of the first 24 terms of a GP is 2. And that's weird. Okay, so and the sum of the reciprocals, okay, the sum of the first reciprocals, the first 24 reciprocals of the terms is unity, which means it's 1 if the product of the first 24 terms of the series is 4. Oh, okay, so we are given 3 conditions over here. Let's start with the first condition. Suppose the GP is AR squared and so on, and you go till first 24 terms, so you are going to go till AR to the 23rd, right? So A plus AR and all the way till AR to the 23rd. There are going to be 24 terms in this, so you can use a formula. Is the first terms time r to the 24 minus 1 upon r minus 1, right? This is going to be 2. And then you have the sum of the reciprocals of the first 24 terms is unity. So when you have 1 over a plus 1 over a into 1 over r plus 1 over a into 1 over r squared all the way till 1 over a into 1 over r to the 23rd, that's going to be 1 over a into, well, 1 over r to the 24th minus 1 upon 1 over r minus 1. Oh, this is going to be some heavy algebra stuff. So 1 over r to the 24th minus 1 over 1 over r minus 1, whatever this thing turns out to be. This thing is 1. Okay, what next? What are we given? If the product of the first 24 terms of the series is 4 to the n, the product of these terms, like a into ar into all the way till ar to the 23rd, so that's just going to be how many of a's do you get? Obviously you get 24 a's, and then you will get r to the 0 plus 1 plus 2 all the way till 23, right? That's going to be equal to a to the 24 times r to the, what's this going to be? So 23 plus 1 is 24 upon 2 is just 12. So 12 into 23, 12 into 23 is like 46, and plus 120 is yeah, so 166, I think. Yep, 166. And this is going to be 4 to the n. Wow. I was not expecting this kind of stuff. Oh, wow, just wow. Okay, now let's start with the first equation. Oops, let's start with, why does this happen so often? Okay, let's start with this equation first. So a times r to the 24 minus 1 upon r minus 1 is 2, and also this one, because you see there is some similarity between this, right? So let's try it out. Maybe you should just multiply these two equations. That will kind of work. Let's first of all simplify the second equation to see what we get. 1 over a into Well, this is going to be 1 minus r to the 24 complete divided by r to the 24 divided by 1 minus r upon r, okay, which can be written as 1 over a into r to the 24 minus 1 upon r minus 1, yeah, into this thing 1 over r to the 24, and then it divides by 1 over r, so we get 1 over r to the 23rd. Oops, what just happened? R to the 23rd. Okay, this is going to be equal to 1. Alright, so what we can do is that we can notice that this thing is in common with this equation. So whatever this complete thing is, that's going to be 2 upon a. So when you just substitute that as the values, so you just get 1 over a squared into 1 over r to the 23rd. That's 1, which means that a squared times r to the 23rd is going to be equal to 1. Now let's try to put this thing in this, right? So let's just raise this to the 12th power on both sides, so you just get a to the 24 times r to the 23rd into 12, which is exactly this, which is exactly this thing, right? 166, because obviously this was actually 2030 to 12, and that's going to be equal to 1, but this was also equal to 4 to the n. So what is n? N is going to be 0. That's it. Find the value of n. N equals to 0. Yeah, this was easy. Actually not that easy, but you get the thing that it was not that hard. So okay, let's do this question. Find the sum of the following geometric series. 0.15 plus 0.015 plus 0.0015 plus all the way till 8 terms. Okay, so 0.15 can be written as, you know what, we can just factor out a 15 from everything, so this would just be like 0.01, which is nothing but 1 upon 100, then 0.001, which is going to be 1 over 1000, and so on. So let's see what we get. This is obviously it's just a GP. Instead of factoring 1.5, sorry, instead of factoring 15, let's just factor out 0.15 altogether. So it's going to be 0.15 into what's the remaining stuff? 1 plus, oops, where's this 1? 1 plus 1 plus 1 by 10 plus 1 by 100 all the way till 8 terms, right? So 1 over 10 to the 7th, I think. Yeah, correct. That's nice. So which is equal to 0.15 into, now you can use the formula for sum of a geometric progression. This is going to be first term, which is a, r, which is 1 over 10 to the 8th power minus 1 upon 1 over 10 minus 1. Wow, this is very weird. So this is going to be equal to 0.15 into 10 to the 81, sorry, 10 to the 8 minus 1 upon 10 minus 1. Alright, but then there's this 1 over 10 to the 8 and divided by 1 over 10, so you just get 1 over 10 to the 7th. So 1 over 10 to the 7th. Okay, and there are no options, so we just have to calculate this, or maybe like just leave it like this. So that will be good if you could just leave it like this. Okay, so here's the deal. You can write this as 0.15 into like 1. Probably that won't work, so let's write it like this. Yeah, let's write it like this. It's going to be 15 upon 10 to the 9 into 10 to the 8 minus 1 upon 9, which is nothing but 5 by 3 into 10 to the 9 into 10 to the 8 minus 1. Okay, so what can we do with this thing? Here's the deal. We can write it as 5 by 3. Well, that can be a problem. um, you will eventually have to write this 10 power 8 minus 1 as 8 nines, which is not cool. So maybe this is the whole answer. Maybe we should just leave it like that. Yeah, that will be cool. Or maybe we can just simplify it further, like simplify it further a little bit. So this would be 10 to the negative 1 minus 10 to the negative 9. Yeah, this looks more simplified and better to look at. So that's going to be the answer of this question, right? The first question is like done almost, and the next question, okay, this is another GP problem, and that is also up to 8 terms. Okay, let's just erase this. Erase, yeah. Okay, so the next thing is, so the next question is root 2. Okay, so you have like root 2 plus 1 over root 2, which you can clearly see is root 2 divided by 2. So I'm going to write it like that, root 2 divided by 2. And then the next thing is 1 over root 2 divided by 2, which can be written as root 2 divided by 4. And it keeps on going like this till you get 8 terms. So it's going to be root 2 divided by 2 to the 7th power. Not a big deal. So you can just factor out a root 2 from this, and then you can use the formula for Jeopardy progression. Or even if you don't factor out, it's okay. So the first term is obviously root 2 times the ratio, which is just half, and this is to the 8th power minus 1 upon 1 by 2 minus 1. Okay, that's nice. This is going to be root 2 times 2 to the 8 minus 1 upon 2 minus 1, which is 1. But then there's going to be 1 over 2 to the 8 divided by 1 over 2, just 1 over 2 to the 7th. Okay, what's that going to be? That's going to be like root 2 times 2 minus 1 over 2 to the 7th. And I will just leave it like that because I don't want to get in all that calculation. You can do it with a calculator, that would be much better. Okay, let's move on to the next question. And at this point I'm getting bored with this question. Oh, third looks interesting. It's just 2 by 9 minus 1/3 plus half minus 3/4. What's the pattern in this? Like 2 by 9. So okay, minus 1/3. So you decrease the numerator by 2 and decrease the denominator by 3. So in short, just multiplied by 3 by 2 over there. Yes, actually by negative 3 by 2. So this is also just a GP thing, right? This is also a GP, but with the thing that the common ratio is negative. Just erase this first, this is getting in our way. Okay, so the next question is also a GP, but with the thing that like its common ratio is negative 3 by 2. So the first term is obviously 2 upon 9. Okay, and then there's this negative 1 by 3, no, negative 3 by 2, sorry, that's the common ratio. 5 terms minus 1 upon negative 3 by 2 minus 1. Alright, now let's simplify it. This is going to be 2 upon 9 into 3 to the 5th, like negative 3 to the 5th is obviously negative 3 to the 5th. So negative 3 to the 5th minus 2 to the 5th upon negative 3, negative 2. But then there's going to be this thing like 1 over 2 to the 5th and then divided by 1 over 2, so it's going to be 1 over 2 to the 4th. I think this might not be that bad. We can actually simplify it. Yeah, it looks like that. So this is going to be 2 upon 9, and just factor out a negative from everything, so we just get like a 5 in the denominator and then 3 to the 5th plus 2 to the 5th. And yeah, you can see it's like maybe just write this as 1, that will be better. So 1 over 9 and then 1 over 2 cubed, that's correct. Why did I write it like that? I don't know. Oh, I erased the wrong one. So this is 2 by 9 and this is actually 1 over 9. Okay, cool. So let's like simplify this first. So it is 1 over 9 and then 3 to the 5th. 3 to the 5th is 3 to the 3rd times 3 to the 2, which is 27 times 9, which is 18 and 63, which is 243. Yep, 243 plus 32 divided by 5. And then this complete divided by 8. Alright, let's see what this thing is. This is going to be 1 over 9 into 8 into whatever this thing is. Well, this thing is going to be, let's see, this 243 plus 32, that's going to be 275 divided by 5, which is 1 over 9 into 8 of 25 is 5 and then 25 is just 5 once again. 55. That is nice. So 55 and yeah, that's it. That's correct. 55. So this can't be simplified any further. Just going to write it as 55 upon 72. That's it. That's the answer. Let's move on to the next question, which is x plus y plus x squared plus xy plus x. Oh wow, that looks like a nice question. Yes, that's a nice question. So you have x plus y plus x squared plus xy plus y squared plus x cubed plus x squared y plus xy squared. Okay, this goes on till n terms. This is an interesting question. Let's deal every term individually to see. First of all, just erase this. That's a nice question. I mean, a really nice question. Okay, I mean, it looks interesting. So x plus y is x to the first plus y to the first. What we can do is that we can factor out an x from this. So you would get x into 1 plus y by x. Okay, and then similarly you can factor out an x squared from the next term, leaving us with 1 over y by x plus y by x squared. And then similarly you can factor out an x cubed from the next one. I don't know if this is correct, like we are going in the right direction or not, but whatever, let's just do this. So it's going to be 1 plus y by x plus y by x squared plus y by x cubed, and so on. Like it goes like that. So just put dot 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 dot, and then it's going to be x to the n terms, and then 1 plus all the way till y by x to the nth term. Now let's try to simplify this. Like let's just try to simplify the last term first, so that we will be able to see what happens to every term in general, because this is more or less a general term. So when you simplify this, that just okay, let's put the arrow maybe. Okay, when you simplify this, this just gives us x to the n times, the first term is 1, the ratio is y by x, there are n terms, that's nice. So y by x to the n minus 1, then divided by y by x minus 1. Okay, so that can be written as, let's just write that as, you can multiply this x to the n inside the bracket, so you would get y to the n minus x to the n upon y minus x, and then this complete thing multiplied by x. So this is going to happen with every term, and you get this x upon y minus x as a common thing in every term. That's nice. So now we are ready to simplify this further. So just erase some stuff first of all. Yeah, you know what, just we will maybe need this. Okay, just erase this. Okay, let's simplify it. So when you put n equals to 1 over there, because like, okay, that's nice, uh, you just get y minus x into x, which is decently good. What we can do is that we can factor out this x upon y minus x first, and then you will have y to the 1 minus x to the 1 plus y to the 2 minus x to the 2, and you can already see that this is going to be two separate gp's in subtraction, so it's going to be y to the n minus x to the n, bracket complete. Okay, that's nice, which can be written as x upon y minus x into well, hey, but why is this so unsymmetric? I mean, x upon y minus x, but we don't care, just do this. Okay, so y to the first minus x to the first plus y squared minus, so y to the first plus y squared plus all the way till y to the n, that's just going to be y into y to the n minus 1 upon y minus 1. Similarly, it's going to be, oops, it's not supposed to be plus over there, it's supposed to be minus of x into x to the n minus 1 upon x minus 1. So now let's simplify this. We can multiply this x upon y minus x into these two things, or maybe you can just deal it directly by cross multiplication, but whatever, this is almost the final result. We just need to simplify this and we will be done. Is there anything which you can take from common, like no, I think that's it. Yeah, this should not be simplified any further, that's it. So I just leave it like that. Are there options in this? No, I don't think so. So that's it. I mean, this is more than good enough for calculation purposes. Like if you ever have to put values of x and y into this and value of n, it is good enough for a calculation. So let's just leave it like that. Okay, so let's do the next question, which is 3 by 5 plus 4 by 5 squared plus, first of all, let's just erase this. Oops. Just erase this. Yeah. Okay, so you have 3 by 5 plus 4 by 5 squared plus 3 by 5 cube plus 4 by 5 cube. Oh, so this is two different gps, and they specifically put a 2n over there. So there are two n terms, which means that there are going to be n terms of the first gp and n terms of the next gp. So this is going to be n terms of this 3 by 5 plus 3 by 5 cube plus 3 by 5 to the 5th power stuff, and then this will be n terms of this 4 by 5 squared plus 4 by 5 to the 4th gp. So these are just two separate gps, you can deal it directly. So the first term is going to be 3 by 5. The ratio is 1 over 5 squared, and then there are n terms of this minus 1, and then you divide this by 1 over 5 squared minus 1. That's nice. And then similarly, this other gp is going to be 4 by 5 squared into this complete stuff is like common, so 4 by 5 squared into n minus 1 upon, like, upon 1 by 5 squared minus 1. All that stuff is just common. Okay, so what is this? So we can just factor out this common stuff from it. So you just get like, first of all, just simplify this common stuff. No, just factor it out first. So you get 5 to the 2n minus 1 upon 5 squared minus 1, and then there is going to be 1 over 5 to the 2n upon 1 over 5 squared, which is just going to be 1 over 5 squared to the 2n minus 1 power, and then there's extra things like, okay, so n minus 1 power, so it's going to be 1 over 5 to the 2n minus 2, and then there is this extra 1 over 5, so it's going to be 1 over 5 to the 2n minus 1. So this complete thing is times 1 over 5 to the 2n minus 1. Then you have the remaining stuff, which is 3 plus 4 by 5. Maybe you should just take out another one from it, like, yeah, that will be better. So just erase this. Okay, this is cool. 1 over 5 to the 2n. What's with this width of, let's start this. Okay, sorry for this. Okay, so it's going to be 1 over 5 to the 2n itself, because now you will be like taking out 1 over 5 squared from it. So times 3 into 5 is 15 plus 4, this is 19. Okay, so it's going to be 19 upon 25 minus 1 is 4, so 19 upon 24 into 5 to the 2n minus 1 upon this thing's like 1 minus 1 over 5 to the 2n. That's nice. So whatever, like, this simplifies to further, you can just write it like that. But I think this is good enough. This is pretty simplified, so that's going to be the answer. So just erase this. Okay, so the next question is 1 minus a squared minus b. Too easy. This is like too easy. So the first term is a, which is the first term is 1. The ratio is minus a. There are how many terms? To n terms. So minus 1 to the n minus 1 upon minus a minus 1. That's nice. Okay, so it depends if n is even or whatever. So that's it. That's the whole answer. You can't simplify it anymore. So that's the answer. It was too easy, right? So like, if you want to simplify it even further, you can write it as negative a to the n plus 1 power, and then plus 1. Yeah, actually, wait, sorry, did something wrong. Sorry, negative 1 to the n plus 1 power times a to the n plus 1, and then this complete thing divided by a plus 1. Okay, just multiply by negative 1 on the denominator and the numerator, so you get negative 1 to the n into negative 1, which is this thing, negative 1 to the n plus 1, and then times a to the n plus 1 upon a plus 1. Let's put bracket. Okay, whatever. So hopefully you understood what I wanted to say, and this was like very easy, so not good. Let's do the next question, which is x cubed, x to the 5th, x to the 7th. Oh shit, this is too easy. I mean, I don't even want to do this, but just because we have to complete this video, let's just do this. So it's going to be x cubed, the first term, times the ratio is x squared, so to n terms it's going to be x to the 2n minus 1 upon x squared minus 1. That's it. That's the whole thing. No simplification. Like, this was very easy. Okay, the next is root 7 root 21. Come on, this is just a common ratio of root 3 and the first one being root 7, so easy. Root 7 times root 3 to the n minus 1 upon root 3 minus 1, and then just put down a bracket. It's easy. Oops. Why does this happen? Yes, it's just too easy. Let's go to the next question. Evaluate the following. The summation from 1 to 11 of this thing, 2 plus, oh come on. Okay, let's just do this. So the summation from 1 to 11 of 2 plus 3 to the n, that's going to be, well, 1 to 11, this is just 11 numbers, so 11 twos is 22, and then this is going to be 3 plus 3 squared all the way till 3 to the 11, which is just 3 into 3 to the 11 minus 1 upon 2, because 3 minus 1 is 2, so this can be written as 22. Oops, why did I put this 22? I'll just write it like this. 22 minus 3 by 2 plus 3 to the 12 upon 2. Yep, that's easy. Yep, too easy. In fact, why don't we just kind of calculate it up? So yeah, it's not too bad. We can calculate this. So 22 plus 3 times, but we want to calculate 3 to the 11, which looks easy. Let's just calculate this, in fact. So you got 3, the first is 3, 3 to the second is 9, 3 to the third is 27, 3 to the fourth is 81, 3 to the fifth is 243, 3 to the sixth is, well, I think 729. Yep, 729. And 3 to the seventh is, well, 9 times 3 is obviously 7, so 7, sorry, 20, shit, 7, 2 carried on, you got, okay, 7 and then 2 carried on, and then 6 plus 2 is just 8, and then you have 2 1 over there. Okay, let's go to the 3 to the 8 is, okay, 1 2 carried on, 24. Maybe it's not that easy, so I'm quitting on this job. I won't be calculated 3 to the 11, but it's okay, you can actually calculate it. It's not too big to calculate, so that's going to be the answer. Let's move on to the next question, which is, what is it? Yeah, summation from 1 to n of this thing, 2 to the k plus 3. Oh, come on, another GP. This is boring. This is going to be, okay, this is going to be the summation from 1 to n of what? This is 2 to the k plus 3 to the k minus 1. Okay, which if you just write down is going to be 2 plus 2 squared all the way to 2 to the n plus 1 plus 3 all the way to 3 to the n minus 1. This is boring. This is just going to be like 2 times 2 to the n minus 1 upon 2 minus 1. 2 minus 1 is just 1, so it's going to be 2 times 2 to the n minus 1, which is just 2 to the n plus 1 minus 2. This is simple. This is just 3 to the n minus 1 upon 2. That's it. You don't even need to do anything more. Okay, this is like an easy question. Okay, the next one is summation from 2 to 10 of 4 to the n. Why do you do this to me? Okay, this is 4 squared plus 4 cubed all the way till 4 to the 10th, which is 4 squared into, the ratio is 4. How many terms are there? From 2 to 8 there are 9 terms, right? So 4 to the 9th power minus 1 upon 4 minus 1 is just 3. That's it. I'm not going to simplify it anymore. That's it. Okay, so just erase that. Let's move on to the next question. Find the sum of the following series. This is almost the same kind of question which we did for that yeah, we have already done this kind of question once, and now I'm bored with these questions, and I am perfectly sure that I will be able to do such questions if I ever get them in an examination. So I'm just going to skip these questions. Okay, I'm going to skip this complete fourth thing. So just move to the fifth one. How many terms of the GP 3, 3 by 2, 3 by 4 be taken together to make 3096 upon 5 and 2? This is just another summation of GP application. Okay, so 3 by 2, 3 by 4, which is pretty much like 3 into 1 plus half plus 1/4, so on, which is nothing but like the first term is 1, and then the half is the ratio to half to the nth power minus 1. So half to the n power minus 1 upon half minus 1 is just half, huh? Which is going to be, well, let's see, what can you do with this? This is going to be 3 times half to the n plus 1 minus 3 by 2. No, sorry, not minus 3 by 2, so plus 6. Okay, so first of all, okay, so this 2 goes up, I think. Then this should be a minus 1 over there, not a plus 1. That's not what I wanted. And minus 1, right, because yeah, it gets reduced once, so that's nice. And then it's divided by that, so 1 over 1 half is obviously 2. So 6 minus 6 is equal to 3069 upon 512. And yeah, I should have like reduced by 3 at the very start, but whatever, it still works. So half to the 2 and half to the n minus 1, and then minus 2 is equal to 1023 upon 512. Okay, so just I'm going to add 2 on this side, which becomes 1023 plus what is it, 1023 plus 1024, which is 20. Wait, something is not correct, because that's not how it's supposed to be. I think it could have been better if it was minus 1 or something. And that should be, no, something is wrong in this. Yep, something is wrong. So after that, minus 1 minus 6 equals to this thing. This should be a plus 2, but that doesn't make sense. No, something is completely wrong. Shit. I mean, oh shit, this should not have been half, this should have been negative half over there. So this complete is like, okay, so there's supposed to be a negative over there, and this is supposed to be a positive quantity. That's the whole problem. So when you just reduce by 3, you should get like this thing is actually negative in that case. So when you do this, you just get 1 over 1024, no, 1 over 512. Yeah, so 1 over 512, which is 1 over, what's this, like, this is 2 to the 9th power. So n minus 1 is equals to 9, implies like n equals to 10. That's it. So okay, that's a question. How many terms of the series 2 plus 6 plus 18, now this ratio is 3, must be taken to make the sum equal to 728? Just another question which is bad. So 2 into 3 to the n minus 1 upon 3 minus 1 is 2, so you can just cancel this out. This should be equal to how much? 728. Oh, which means that n should be, 729 is 9 cube, which is 3 to the 6th, so n should be equal to 6. That's it, really. What's this? Okay, n should be equal to 6. Okay, so there should be 6 terms to make the sum equal to 728. How many terms of the sequence root 3 root 3? Okay, so the common ratio is root 3, must be taken to make the sum 39 plus 13 root 3. Okay, let's do this. So there we go. I think, okay, let it be. So this is going to be root 3, 3 root 3 plus okay, so the first term is root 3. The common ratio is also root 3, so root 3 to the nth power minus 1 upon root 3 minus 1. This should be equal to 39 plus 13 root 3, and you can see the denominator is rationalized for this question, so I will be rationalizing the denominator as well. Okay, or maybe not, just let's do it like this: root 3 to the n plus 1 minus root 3. This is equal to, well, root 3 minus 1 times this thing, so 39 root 3 plus 39. Why does this happen? Plus 39 and then minus 1, so minus 39 minus 13 root 3. Okay, cool. So from that we can say that root 3 to the n plus, actually instead of that let's just write root 3 times root 3 to the n minus 1 is equal to root 3 times 39 minus 13, which is, yep, just 26. Okay, so that means like you can just cancel these away. So you would have root 3 to the nth power is equals to 27, so 3 to the n by 2 is equals to 27, which is obviously 3 cubed, so n by 2 equals to 3, which means that n should be equal to 6, so 6 terms should be taken, so that the sum is this thing. What was the thing? 39 plus 13 root 3. The sum of n terms of okay, the next question is the sum of the n terms of the GP 3, 6, 12 so on is 381. Find the value of n. This is boring because now these are just repetitions of the question. 3, 6, 12, or the common ratio is 2, so 3 times of 2 to the n minus 1 is equal to 381. Now you can see that I didn't write 2 minus 1 because 2 minus 1 is going to be 1. So from this you can say 2 to the n minus 1 is equals to 127. So 2 to the n equals to 128, which is 2 to the 7th, so n equals to 7. Easy. So that's it. Let's go to the last question. The common ratio of a GP is 3 and the last term is 486. If the sum of these terms is 728, find the first term. Too easy. So there is an alternate formula for the sum of the terms of a GP. I think all of you know that the sum of the terms of GP is given by a times r to the n minus 1 upon r minus 1, which can also be written as r times a to the r to the n minus 1 minus a upon r minus 1. Now why did I write it like this? Because this a times r to the n minus 1, this is the last term of the GP. Just call this L for now, so LR minus a upon r minus 1. Okay, so we are given the last term is 486, so 486 times what's the ratio? Common ratio of a GP is 3, so minus the first term upon 3 minus 1 is just 2. This is supposed to be equal to 728. Okay, this is easy, but just involves a lot of calculation. So let's do this. 786 times 3. What should that be? Like this should be 18. 1 carried on 24, so it should be 5. And then 2 carried on and 12, so 1458 minus a should be equal to 6, and then 1 carried on, so 4 plus 1 just 5, and then 1456, which means that a is equals to 2. That's it. That's the answer. So, and yet only half of the homework is done, even though I have spent a lot of time doing this. Right, there's still a lot of questions to be done. So It's okay. I'm going to take a break and I will be doing the other questions later. Or maybe let's just do this right now. Yeah, let's just do this right now. There are like 5 questions left. It should not take that much of time. Let's just do this. So first of all, just gonna switch off this thing. Okay, so the ratio of the sum of the first 3 terms is to that of first 6 terms of a GP. Acha. Okay, so the ratio of the sum of the first 3 terms is that. Okay, so we are given a ratio uh, to that of the first 6 terms of a GP. Okay, is 125 is to 152. Find the common ratio. So you're given like a plus ar squared. This is the sum of the first 3 terms. This is in ratio with the sum of the first 6 terms. So a plus ar all the way till ar to the 5th. This thing is going to be, this ratio is 125 is to 152, right? 152. So we can just reduce this ratio with a, that's okay. So that will just give us 1 plus r squared, which is just r cubed minus 1 upon r minus 1 is to r to the 6th minus 1 upon r minus 1 is equals to 125 is to 152, which means that r cubed minus 1 is to r to the 6th minus 1 is equals to 125 is to 152. So now we can factor this r to the 6 minus 1 as r cubed minus 1 into r cubed plus 1. So this ratio can be further simplified to 1 is to r cubed plus 1 is equals to 125 plus 152. Okay, which means that r cubed plus 1 is equals to, wait, why is this a plus over there? Okay, so 125 is to 152. R cubed plus 1 is nothing but 152 upon 125, which means that r cubed is going to be equal to, let's do this, 7 to 277 upon 125. Is 277 the cube of something? We don't know. Just make some more space. So 277, I don't think it's a cube of something. 277, yeah, 277, like 9 and 7. No, it's not divisible by 11. Is this divisible by 2? Obviously not by 3. I don't think so. What about 7? 20, 28, so like 21, and then you would get 67. No, that's not working. Oh shit, sorry. There's supposed to be 152 minus 125, so this is not what I thought it would be. Man, I should stop making such mistakes. 152 minus 125 is also like 12 minus 5 is just 7, and then you have 4 minus 2 is just 27. Oh, 27 is obviously a cube of something. It's the cube of 3. So 3 cubed is nothing but 3 upon 5 cubed, which means that r is equals to 3 upon 5. Okay, so find the common ratio. It's just 3 by 5. The fourth and, okay, just erase this now. The fourth and 7th term of a GP are 1 by 27 and 1 by 729. Okay. Oops, what is this thing? 1 by 27 and 1 by 729. Find the sum of the n terms of the GP. So the 4th term is going to be ar cubed and the 7th term is going to be ar to the 6th. So when you take their ratio, you just get r cubed. So r cubed equals to 1 over 729 divided by 1 over 27. Well, 1 over 729 is nothing but 1 over 27 into 9. So when you divide it by 1 over 27, you just get 1 over 9. So r cubed equals to 1 over 9. Okay, find the sum of n terms of whatever. Yeah, that should be like that. So r2 is like r cubed 27. It's like 9 cubed. No, sorry. So 27, right? Oh yeah, so 1 over 729 is nothing but 1 over 27 into 27. So you get r cubed equals to 1 over 27, which means that r equals to 1 by 3. Okay, that's not bad. So r equals to 1 by 3. So what we can do from that is that ar cubed is equals to 1 over 27. When you put r equals to 1 by 3 in this, you just get a is equals to 1. Okay, that's nice. And then and yeah, if you know a and you know r, you can obviously find the sum of n terms of the GP. So sum of the n terms is going to be a, which is 1, into r, which is 1/3 to the nth power minus 1, divided by 1/3 minus 1. This is what is this thing? 1/3 minus 1, which is nothing but 3 to the n minus 1 upon 3 minus 1 is just 2, and then this is going to be divided by 3 to the n minus 1. Yep, that's correct. So that's going to be the answer. And yeah, it can be simplified further to give us um, half of 3 minus 3 to the 1 minus nth power. Yeah, okay, that's nice. So this question is almost done. Actually completely done. Find the summation from 1 to 10 of half to the n minus 1 plus 1/5 to the n minus 1, sorry, n plus 1. So just two different GPs added together. Yeah, it's boring. We have done these kind of questions before, so I don't even want to do it, but this is just the last 5 questions, so I should actually be last 6 questions. Okay, I should just do it. So summation from 1 to 10 of half to the n minus 1 plus 1/5 to the n plus 1. Okay, this is nothing but when you put n equals to 1 in this, you just get 1. So 1 plus half plus 1/4 all the way till 1 by 2 to the 9th, and then plus you put 1 in this, you get 1 over 5 squared. So 1 over 5 squared plus 1 over 5 cubed all the way till 1 over 5 to the 11. That's it. So this is going to be, the first term is obviously 1, the ratio is 1 by 2. There are 10 terms in this, so it's just going to be 1 by 2 to the 10th power minus 1 upon 1 by 2 minus 1. And then this thing is going to be, the first term is 1 by 5 squared into the common ratio is 1 by 5. There are 10 terms, so 1 by 5 to the 10th power minus 1 is divided by 1 by 5 minus 1. Oh, this is taking all eternity. Okay, what happened? Okay, so this thing is nothing but, okay, so 2 to the 10th minus 1 upon 2 minus 1 is just 1, so that's cool. So 2 to the 10th minus 1 upon 1, and then this 1 upon 2 to the 10th upon 1 upon 2 is just upon 2 to the 9th, and then this thing 5 to the 10th minus 1 upon 4, 5 to the 10th minus 1 upon 4, and then this is like 1 over 5 to the 10th upon 1 over 5, essentially 1 over 5 to the 9th power, but that times 1 over 5 squared is 1 over 5 to the 11th power. So 4 into 5 to the 11th power. It's like addition. Okay, that's it. That's the sum. I don't think I will be simplifying it. Whatever. Just leave it like this. This was easy. Let's go to the 13th question. The fifth term of a GP is 81, whereas its second term is 24. Find the series and the sum of its first 8 terms. The fifth term of a GP is 81, whereas its second term is 24. Okay, so a sub 5, which is just a into r to the fourth power, is nothing but 81, whereas its second term, which is obviously ar, is 24. Find the series and the sum of its first 8 terms. Okay, simple. Let's just divide these two equations. So you get r cubed is nothing but 81 upon 24, which is just 27 upon 8, which is 3 by 2 cubed, which means that r equals to 3 by 2. Okay, cool. So just put r equals to 3 by 2 in this equation. So you get a into 3 by 2 equals to 24. So 3a upon 2 equals to 24, which means that a equals to 16. What are we supposed to find? Yeah, find the series and the sum of its first 8 terms. So it's just going to be 16, and then 8, like 24, and then into 3 by 2, so 12 into 3 is just 36, and keeps on going like that. So we want to find the sum of its first 8 terms. Well, that is going to be that is going to be like a is 16 times the ratio is 3 by 2 to the 8th power minus 1 upon 3 by 2 minus 1. Okay, this is going to be, what is this? This is going to be 16 into 3 to the 8th power minus 2 to the 8th power, and then this is just going to be 3 minus 2 is just 1, and then you have 3 by 2 to the, okay, you have 1 by 2 to the 8th power divided by 1 by 2, which is just 1 by 2 to the 7th power, so like 1 over 2 to the 7th power, which is nothing but, well, 16 is nothing but 2 to the 4th power, so this is going to be 1 over 2 to the 3rd power into, what's 3 power 8? Oh god, this is going to be, okay, let's just do this. 3 to the 8, I think we calculated it somewhere, whatever, let's just calculate it once again. So yes, we will be calculating it once again, and instead of doing is 3 to the 8, let's just do this as 9 to the 4th. That will be better. We already know that 9 cubed is nothing but 729, so 9 to the 4th cannot be that different. Wait, what? 9 cubed is 729. Yes, correct. And then 9 to the 4th is going to be, is times 9, so you get 81, 8 carried on, so you get 18, 8 is 26, 6 2 carried on, 263 and 265, so 6561. Okay, so instead of writing as 9 to the 4th, let's just write this as 6561 minus 2 to the 8th power, which is not that hard to calculate, so it's just going to be 128 times 2, which is just 256, and then that's it. This is just going to be 1 over 8 into whatever this thing is. 11 minus 6 is 5. Yeah, 5 minus 5 is just 0. And then 4 minus 2 is just 2, 66205 something. That's it. 6205 upon 8. 6205 upon 8. That's going to be the answer. Which question was this? Oh yeah, 13th question. Let's go to the 14th question. If S1, S2, S3 respectively be the sums of n, 2n and 3n terms of a GP. Okay, sums of n, 2n and 3n terms of a GP, then prove that S1 squared plus S2 squared equals to S1 into S. Okay, we just have to write it down. So S1 is going to be a times r to the n minus 1 upon r minus 1, and instead of writing as upon minus 1, just write it over here. So a upon r minus 1 is going to be a common thing in all of them. S2 is going to be a upon r minus 1 into r to the 2n minus 1. and oops, sorry, S3 is going to be a upon r minus 1 into r to the 3n minus 1. So what I'm going to do is that I'm going to write this a upon r minus 1 as capital A. I'm going to write r to the n as b minus 1, and this thing can similarly be written as a into b squared minus 1. Right. This looks much easier to do, so a into b cubed minus 1. Right, now it's much easier to actually do. So what we're supposed to do, yeah, s1 squared plus s2 squared, that's going to be this thing squared plus this thing squared. Just make more space for ourselves. Okay, that's going to be a squared times b minus 1 squared plus b squared minus 1 squared. What I'm going to do is that I'm going to factor out a b minus 1 squared from both of them, and then you just have 1 plus b plus 1 squared, b plus 1 squared, and this is supposed to be equal to s1 times s2 plus s3. But s2 plus s3 is this plus that, which is b cubed plus b squared minus 2. So this is supposed to be equal to a squared times b minus 1 times b cubed plus b squared minus 2. And yeah, it looks like that because this is basically just a squared into b minus 1 times, but this can, I think this can be factored out. Yeah, because yeah, so b minus 1 can be factored out from this. I don't know what we get on factoring it. I think we should just factor out it. So we should divide it by b minus 1 to see what we get. So we are going to divide b cubed plus b squared minus 2 by b minus 1. Okay, so you get b squared over here, you get b, oops, what happened, you get b cubed minus b squared over there. Alright, so you subtract it out, you just get what is this, you just get 2 into b squared minus 1, which by the way can also be written as 2 into b minus 1 into b plus 1. So now it's clear that you just have to like add 2 into b plus 1 into this thing. So that's just b squared plus 2b plus 2. Alright, so that's what you get when you factor out a b minus 1 from this thing, b squared plus 2b plus 2. So what happened, okay, b squared plus 2b plus 2. So just put that over there. So b squared plus 2b plus 2. Okay, now let's see if this equation is correct or not. So b minus 1 squared is there, 1 plus b plus 1 squared is obviously just 1 plus b squared plus 2b plus 1, which is just 1 plus, oh sorry, which is b squared plus 2b plus 2. Yes, this is correct because this thing is the same as this thing, and this thing is the same as that thing. So yes, this is correct. So we have almost proved it. Now I just need to like backtrack everything, and yeah, anybody can do it, even when like a child can do that. So that's done. Okay, let's do the next question. If s1 s2 so on till sn are the sums of n terms of n gp's whose first term is 1, and in each and common ratios are 1, 2, 3 all the way till n respectively. Okay, then prove that. Wow, this is very weird. Okay, so which means that s1, wait, what happened, why is this, which means that s1 is going to be nothing but the first term is 1, the ratio is 1 for s1, so it's going to be 1 to the n minus 1 upon 1 minus 1. You can't do that, right? So this is not cool. So I'm going to write it differently. I'm going to write it as 1 plus 1 plus 1, so on, and then there are going to be n ones over here. So n ones, this thing just turns out to be n itself. Okay, s2, the first term is 1, the common ratio is 2, so this is good. You just have to the n minus 1 upon 2 minus 1, 2 minus 1 just 1, so we don't have to worry about that. S3 is 3 to the n minus 1 upon 2, so on. Okay, what are we supposed to prove? Wait, what? The question is incomplete, so no, I'm not going to do this. That's it. I'm completed my homework. That's it. I'm not going to do this question anymore. Okay, hope you enjoyed this video. Thanks for watching.